Hello everyone. So today we are gonna discuss Hare'S apparatus. So it is an apparatus which is used to find the relative density of any substance, and relative density is the ratio of the density of liquid to the density of water. So now let's discuss that what is Hare'S apparatus. So it's basically that if you take two containers and with one is filled with water and the other one is filled with like say any liquid, both are connected to a U-shaped tube which has a pinch cork in it. We will discuss that what is pinch that why this pinch cork is attached. So it has a pinch cork in it. Pinch cork is something that through which we can suck air. It is like a straw. So now the liquid and water both have a U-shaped tube. Now if I suck air through this, wait, let me mark this. This is liquid and this is water. So now if I suck air through it, then both the liquid rises till a height. I will write it. Okay, so now I have written it that take two bakers, one filled with water and other filled with a liquid of desired choice, and we will connect both the beakers by a U-shaped tube. So if we suck air through it, it is noticed that both the liquid rises till a particular height. So how can we determine that which height that the height which is greater and height it is smaller? How we determine that which height is greater than and which height is smaller. So basically the liquid which has a higher density, then the height will be less, and the liquid which has more density and liquid which has less density, the height will be greater. Okay, so density is directly proportional. Density is inversely proportional to height. Okay, this is density and this is height. So now both the liquid rises till a particular height. Let me call this height as h1 and this height as h2. Okay, clear? So this is height h1 and this is height h2. Mark both these points A and B, and here also C and D. Note that both the point both all the points A, B, C and D are at the same height from the ground. Okay, so we know that according to the laws of liquid pressure that pressure at a point, pressure at a horizontal plane is same at all points. So pressure at A equal to pressure at B and pressure at C equal to pressure at D. Okay, clear? So now let's move on to the calculation. We know that atmospheric pressure acts on A because it is in direct contact to atmosphere. So pressure at A, PA equal to PB, then PA is P naught. Okay, P naught is the atmospheric pressure. PB, now PB is the pressure at point B. uh, Basically the pressure at B is the product of height, density of liquid and acceleration due to gravity. Height of H1, let me call this HL, and H2 as HW. Okay, this is HL and this is HW. So pressure at B equal to HL, DL and G. Also we will add P naught dash. Now what is this P naught dash? This is the uh, this pressure P naught dash is less than atmospheric pressure, because some amount of air will be left in this. It is not possible to suck all the air. Okay, this is P naught dash. Now the similarly, pressure at C equal to pressure at D. So pressure at C is also P naught, and pressure at D is height of water, density of water, acceleration due to gravity, and some atmospheric pressure acts on it. This is, let me call this as P naught dash. So if you see, let me mark both these equations as first and second. If you notice that both equations have equal LHS, so I can equate both these equations. So their RHS will also be equal. HL DL G plus P naught equal to HW dW G plus P naught. From here P naught will be cancelled. Now G will also be cancelled. Now what comes is HL upon H, that DL upon dW is equal to H, that DL upon dW is equal to HW upon HL. So what is DL upon dW? This is density of liquid divided by the density of water. Now this is only called the relative density. So let me call this as RD is equal to HW. HW is height of water column, and HL is height of liquid column. This is what Hare'S apparatus is, that the relative density of two substances is the ratio of height in water column and height in liquid column. So I hope that this is clear. Let us recall what we did. We wanted to find the relative density. The relative density is the ratio of density of a liquid to the density of water. So we took two beakers which were filled with liquid and water, and we used a U-shaped tube to connect both these beakers, which was connected to a pinch cock. We sucked the air through the pinch cock, and it is noticed that both the liquid rise till a particular height. Now we mark point at same height A, B, C, and D. We notice that we have to make sure that that all the point A, B, C, and D are at the same height from the base. Now pressure at A will be equal to pressure at B, because pressure at all points at a horizontal plane is equal. So PA equal to PB. Here PA is equal to P naught and PB is equal to height of liquid, density of liquid, multiplied by acceleration due to gravity, added to P naught dash. P naught dash is the is less than atmospheric pressure. Pressure at C equal to pressure at D. This is also this PO equal to HW dW multiplied by G plus P naught. Since both have equal LHS, then we can say that the RHS is also equal. Now we have cancelled the P naught, and by equating we got that density of liquid upon density of water equal to height of water and height of liquid. This is only called relative density. So now we concluded that the ratio of height of water column to the ratio of height of liquid column is only called relative density. I hope that you learned from this video, and if you learned, please make sure to like this video and subscribe my channel. Thank you.